Ever wondered how long it takes for a transaction on the Newton blockchain to be confirmed? You're not alone. In this video, we'll delve deep into the fascinating world of Newton's transaction verification process, exploring the factors that influence confirmation times and how they impact your user experience. What is Newton? Before we dive into verification times, let's quickly recap what Newton is. Newton is a decentralized blockchain platform designed to facilitate secure and efficient digital asset transactions. It utilizes a unique consensus mechanism, which plays a crucial role in how quickly transactions are validated. Understanding transaction verification. At its core, transaction verification on any blockchain involves ensuring that a transaction is legitimate and hasn't been tampered with. This process is vital for maintaining the integrity and security of the entire network. On Newton, transactions are broadcast to all participating nodes in the network. These nodes then independently verify the transaction's validity. This typically involves checking. Transaction signature: is the transaction signed by the legitimate owner of the funds? Sufficient funds: does the sender have enough funds to complete the transaction? Transaction format: does the transaction adhere to the established rules and protocols of the Newton blockchain? Factors influencing verification time. Several factors can significantly influence how long it takes for a Newton transaction to be verified. Network load. When the network is congested with a high volume of transactions, it naturally takes longer for each transaction to be processed. Think of it like a busy highway. The more cars there are, the slower the traffic moves. During periods of high network activity, such as during market surges or major events, you might experience slightly longer verification times. Block intervals. Newton's blockchain operates in blocks. Each block contains a set number of transactions. The time it takes to create and add a new block to the chain is a crucial factor. Shorter block intervals generally lead to faster transaction confirmations. Node performance. The speed and efficiency of the nodes participating in the network also play a role. If nodes are slow or underpowered, it can slow down the overall verification process. Transaction complexity. More complex transactions, such as those involving multiple inputs or outputs, may take slightly longer to verify than simpler ones. Network connectivity. Reliable network connectivity is essential for efficient transaction propagation. If a node has poor connectivity, it may take longer to receive and process transactions, potentially delaying the overall verification process. Confirmation threshold. In the context of blockchain, confirmation usually refers to the number of blocks added to the chain after a transaction is included. One confirmation, generally considered a basic level of confirmation, indicating that the transaction has been included in a block and is unlikely to be reversed. 6 confirmations, often considered a higher level of security, providing greater assurance that the transaction is irreversible. The number of confirmations required can vary depending on the specific use case and the desired level of security. Improving transaction speeds. While network congestion can sometimes lead to longer verification times, the Newton development team is constantly working on optimizations to improve transaction speeds. These optimizations may include sharding. Dividing the blockchain into smaller, more manageable segments can improve scalability and reduce congestion. Layer 2 solutions. Implementing off-chain scaling solutions can significantly increase transaction throughput while maintaining security. Hardware upgrades. Upgrading the hardware used by nodes can improve processing power and speed up transaction verification. User experience considerations. For users, understanding transaction verification times is crucial for a smooth and enjoyable experience. Real-time updates. Providing users with real-time updates on the status of their transactions can help manage expectations and reduce frustration. Clear communication. Openly communicating potential delays due to network congestion or other factors can help build trust and transparency. Educational resources. Providing educational resources to help users understand the nuances of blockchain technology and transaction verification can empower them to make informed decisions. Visualizing transaction verification. To help you better understand the transaction verification process, let's visualize it. Imagine a network of interconnected computers, nodes, representing the Newton blockchain. When you initiate a transaction, it's like sending a message to this network. The nodes receive the message, verify its authenticity, and then add it to a block. Once the block is added to the chain, your transaction is considered confirmed. Real-world analogy. Think of it like sending a package through the postal service. You drop off your package at the post office, broadcasting the transaction. The package is sorted, processed, and transported to its destination, nodes verifying and processing the transaction. Finally, the package is delivered to the recipient, the transaction is confirmed. While there may be occasional delays in the postal system, the overall process is designed to ensure reliable and timely delivery. Transaction verification on the Newton blockchain is a complex but essential process that ensures the security and integrity of the entire network. While factors like network load and transaction complexity can influence verification times, the Newton ecosystem is constantly evolving to improve efficiency and provide users with a seamless experience. By understanding the factors that impact verification times and staying informed about network developments, users can make informed decisions and navigate the Newton ecosystem with confidence. With that said, thanks for watching, and until next time.